If f of x is equal to e to the 3 natural log of x squared, then what is the derivative of f? And we can look at this a couple of ways. There's probably a simpler way and then a more traditional way of looking at it. So let's always, when I have natural logs, I want to see if there is some way to use the properties of logarithms to simplify the expression before I get started on it. So again, we do have this property in natural logs that says that the natural log of a to the b is really just b times the natural log of a. And so if we were looking at the exponent in this particular expression, 3 times the natural log of x squared, we could kind of go reverse of this. And instead of bringing down the b, which we could do, instead of bringing down the 2 and multiplying, we can bring the 3 back up and multiply it. So 3 ln of x squared, you could on one hand say that's 6 ln of x, and that's also ln of x to the 6th power. So I think that the first thing that I would do in this case is rewrite e to the 3 ln of x squared as e to the ln of x to the 6th power. Then another important property of logarithms is that e to the ln of x is just x. And a simple explanation, hopefully, a logarithm is an exponent. Ln of x is the logarithm that raises base e to equal x. Ln of x is the exponent that raises e to equal x. Well, when we raise e to that exponent that raises e to x, we get x. And so e to the ln of whatever is just whatever. And that's another way that I say it. So this is all just x to the 6th power. So e to the ln of x to the 6th is just x to the 6th. And then if we take the derivative at that point, it's pretty straightforward. It is just 6x to the 5th power, and that is answer E. Now if we were going to do this a little bit more complicated, we have a chain rule. So if f of x is equal to e to the 3 ln of x squared, when we go on to right away take the derivative, well, the derivative of e to the whatever is e to the whatever times the derivative of whatever. And so the derivative of 3 ln x squared again here not using any properties of logarithms would be, we still have the e to the 3 ln of x squared, and now the derivative 3 is just a constant multiple, and so we're going to get 3 over x squared times the derivative of x squared, which would be 2x. And so that is going to give us, when we simplify, that will be 6 over x. And that's times e to the 3 ln of x squared. Now at this point we don't have any answers that look like that, and so we still will have to use the properties of logarithms. And when we do this, we're going to have to go back to this idea that 3 ln of x squared is ln of x to the 6th, and e to the ln of x to the 6th is just x to the 6th times 6 over x, which is going to give us 6x to the 5th. Now there was a lot more work doing it that way than doing it by applying the properties of logarithms first, but either way it's going to work out in the end if you apply everything as it should be done there. Alright, so that's going to be it with this problem. My suggestion would be always with a natural log or any kind of logarithmic expression, see if there's some way to apply the properties of logs first to simplify the expression and then take the derivative of that. Even though it works fine the other way, it's a lot more complicated.